go ahead and we can actually go ahead and annotate this a little bit together because I think that'll help us. So 500 meters, meters, is meters a velocity, a distance, displacement we use pretty interchangeably, or a time? Tell me in the chat box. Meters, is that a velocity, distance, or time? Velocity, distance, or time? Tell me in the chat. Mallory, Jalen, Lena, tell me in the chat. Meters, is that a velocity, distance, or time? Think about a meter stick. What does it measure? How fast you're going, velocity, a displacement or distance, or a time? Excellent. I see Jonathan in the chat. Mal, Shayna, Seraphim. Tell me in the chat. Thank you, Lena. Yeah, so this one is going to be our distance or displacement, which we could label as delta x, just meaning change in position. Again, that's either distance or displacement. And 5 seconds, what is 5 seconds? So I should have 500 meters on top here. What is 5 seconds? Seconds, tell me in the chat. 500 meters on top divided by, our time. This is going to be our change in time right here, which is 5 seconds, which goes on the bottom. So we should be doing 500 meters divided by 5 seconds. And again, we are going forwards. So should our answer be positive or negative? We are moving forwards. Forward direction, is that considered the positive or the negative direction generally? Thank you, Shayna. Thank you, Jonathan. Let's get some more answers. Joseph, Malachi, Callie, Tim, Alicia, Seraphim, Alexander, Alex, Itati. If we're going forwards, what direction is that? Positive or negative? Again, the faster we participate, the less we have to go into passing period. Need everyone participating. Lots of answers. I see 3 people in the chat. I need more. Thank you, Itati. Let's get Mallory, Jalen. There we go. Yeah, so this is going to be in the positive direction. So tell me in the chat, I should have positive what? 500 divided by 5, or circle it up on the board. Positive 500 divided by 5 seconds. Either tell me in the chat or up on the board. Thank you. I have an answer from Jonathan. I need at least 10 people answering me. There are 20 of you. Let's go. Get our answers in the chat. Otherwise, we will go into passing period. So participate. Thank you, Lena. Thank you, Kalina. Thank you, Jalen. Positive 500 divided by 5. I should be getting positive 500, positive 100. Excellent. Go ahead, give me a smiley or an emoji in the chat. I saw lots of people in the chat answering that. I know we didn't see it up on the board, but I do see lots of people in the chat. Excellent, Tim. Thank you. Smiley faces, everyone, if that makes sense. So we would have a positive 100 meters per second for our velocity of our snitch. Pretty fast snitch. All right, so let's go ahead and take a look here. I'm going to send out the links to the notes. I'm going to make sure to grab the physics notes. Awesome. So here is the Larkin version. Here is the Bengal version. Again, if one link doesn't work, try the other link because that one should work. Otherwise, you can get to it from your grades tab, your announcements, your class plan, or your content. It's everywhere. Remember, the reason I want your notes open is because if you do your notes outside of class, then you only get notes credit. Whereas if you do your notes during class, then you get both notes credit and attendance credit. Remember that we do need, Insight policy says that we do need tangible proof that you are here and participating. All right, so that means that I need to actually see that you are participating. I need to actually see you doing your notes in order for you to get to your attendance. You cannot just log in and ghost us. You do need to give us physical evidence that you are here. If you have your notes open, go ahead and raise your hand. If you have your notes open, go ahead and raise your hand because you know I'm going to ask you for that in just a moment anyways. Thank you, Jalen, Cody, Kamal, Alex, Lena, Joseph, H, thank you, Kai, awesome, Shayna, Benjamin, Kalina, great, awesome, Jonathan. All right, let's go ahead and jump into this. This is a reminder, please do not share contact info. Please participate often and well and behave appropriately. Don't forget that these are being recorded for learning purposes that are listed here as always. We are on day 10 out of 60, officially a sixth of the way through the trimester. And take a look here, we have spring break coming up next week. Give me a smiley emoji or a yes in the chat if you're excited about that. I think your teachers are probably more excited than you are. Yes, Itati, Kalina, yes, glad you are all excited. Awesome, Angelina. So this week we're going to be taking a look at going into motion, Newton's laws of motions, a little bit more in depth. So let's go ahead and talk a little bit about that. This is where we are. This is our kind of mind map of this unit. So right now we're going to talk a little bit about acceleration and how forces are related to acceleration. We'll talk a lot more about forces tomorrow, though. But this is a reminder that your Unit 1 paper airplane project was due last Thursday. We will be zeroing it out today. Now, this doesn't mean that you can't still turn it in. You can still turn it in and still get full credit, but you will see your grade drop a huge amount until it is turned in. So remember, it's impossible to pass without that project. You need to make sure that you get it turned in. Otherwise, you won't pass my class, right? You need to actually do the work to earn the grade. If you don't do the work, you haven't earned the grade. Now, that being said, we do grade it on a scale that is to your benefit. Remember, we grade it on a 5 through 10 scale as long as you provide a valid attempt. This is the key word here. Valid means that you don't have any blanks in it. Valid means that you don't have any random answers in it. All right, if you have blanks or random answers, then that does not count as a valid attempt. You will get a 0. It will get deleted and sent back to you. You can't just turn in blank templates and expect to get credit for that. We always just delete them. It gets sent back to your overdue notices. That is not a way to try to trick the computer into getting rid of your work. Okay? Valid attempt means that it's clear that you watch the recordings. All right? So we do go over all the steps, all the slides, and we also give you a ton of the answers in the recordings. So if I give you an answer in a recording, I should see the answer word for word on your project. Otherwise, it's very obvious to me that you did not watch the recordings. Now, so this is to your benefit. If you use the recordings, the lowest grade you could possibly get is a 50%. The reason being, again, remember, we're not trying to penalize you for what you don't know. We're trying to celebrate and encourage you in what you do know. So as long as you try, as long as you use the recordings, pretty much all of my students do extremely well on the projects. You just have to try. You just have to try. If you do want help, you can come to office hours on Tuesdays or Thursdays. We usually have office hours at 2 p.m. Tuesday, Thursday. So if you want help on that, it's a short project. It'll take about 30 minutes to knock out, and then you will have a great project completed. This is a great way to make sure you do really well on your projects, is to come to office hours. So today we're going to take a look at how force is related to acceleration. We'll talk about the different types of acceleration and how those affect velocity, and we will also talk about how to actually calculate acceleration today. We are working on the 2B notes, so again, I do need your 2B notes open and ready to go. Go ahead and, sorry, I lowered your hands. Oh no, okay, go ahead, sorry, one more time, raise your hands. Let me know you have your notes open. I apologize, I didn't mean to lower your hands. I meant to only clear out the green checks, but I must have lowered them. All right, so I want to go ahead and brainstorm in the chat. What happens to your body if the car speeds up very, very fast? Go ahead and tell me in the chat, what does it feel like? Which way does your body move when a car speeds up really, really fast? Tell me in the chat. Learning new things, Tim. Awesome, I see Amari in the chat. What happens to your body? Yeah, it feels like you get pushed backwards, right? So it feels like you are being pushed backwards. Awesome. Now, what about when a car brakes very quickly? What does it feel like your body is doing when someone brakes really fast, slams on the brakes, tries to avoid hitting something, right? Which way do you move this time? Yeah, this time you actually feel like you're being thrown forwards. And finally, what happens to your body when someone sharply turns to the left? What happens when someone sharply turns to the left? Yeah, it does not feel good, does it? What happens when you turn very sharply to the left to your body? Which way does your body actually? Don't get thrown to the left. All right, think about it. You're moving and then someone turns to the left. Which way does your body actually go? No worries, Seraphim. Yeah, you actually get thrown to the right in the opposite direction. So thrown to the right. So hopefully we saw that pattern happening, that whichever way the car is accelerating, your body feels like it goes in the opposite direction. So thrown to the right. Okay, so this is important to understand that we actually know when cars are accelerating based on what's happening to our bodies. If you feel like you are being pushed or pulled in a car, it is a good indicator that acceleration is happening. You're either speeding up, slowing down, or turning. Those are all examples of acceleration. Go ahead and give me a smiley or an emoji in the chat box. So if you feel yourself go forwards, backwards, left, or right, it's a pretty good indicator that acceleration is happening. At least extreme acceleration. Excellent. All right, so let's talk a little bit about what acceleration actually is.
All right, so forces and acceleration. So first of all, let's just take note of the little picture that we have here just to help us understand what forces and acceleration are. We can see that our happy little stick figure is running toward the right, and he says, I'm accelerating because I'm speeding up. Then we have our cool rad stick figure on our skateboard with his hat, and he says, I'm accelerating because I'm slowing down. All right, and then we have a yellow bug, possibly a bumblebee, and it's buzzing all around in this curved path right here. And he says, I'm accelerating because I'm changing directions. So that's what really acceleration is. It's either you're changing your speed or you're changing your direction. Because remember, velocity is speed with direction. So anytime you're changing your velocity, being speed or direction, that counts as acceleration. All right. Then we have some definitions here. Force is a push or a pull. So that brainstorm we just did when we're talking about the forces that you're feeling in the car, the force of you being pushed or pulled or thrown to the right or the left, that is a force that is changing your acceleration with respect to the car. All right. We have an example here. A ball doesn't move until a force is applied, which then changes its velocity. So something that is still is going to tend to stay that way unless you put a force on it, which then gives it acceleration. All right, acceleration is just defined as any change in velocity, including speed or direction. Right, it can be and, but it can be also just be one or the other. All right. So for number 2 on our notes, we will put acceleration. All right, raise your hands for when you have completed number 2. All right, I'll give us about 20 seconds to do this because this is pretty simple. Just write acceleration as it is spelled right here for number 2.
All
Okay,
right,
there we
so
go.
acceleration again is the rate of change in velocity. So if we're talking about a positive acceleration, we mean that that change is in the increasing direction. It's becoming more and more positive. So this happens in two instances. When either you start moving, you go from rest to moving, your velocity increases, and so there's a positive change, or you just get faster. So taking a look here, you can see both of those examples. Again, up here, we can see that we are starting motion, going from rest right here. Rest right here to having a larger speed, or we're increasing our speed. We're getting faster, which you can see down here, right? Going from 7 meters per second to 9 meters per second. That is going to be an increase in velocity. Go ahead, give me smileys or emojis in the chat if that makes sense. Smileys or emojis in the chat if that makes sense. Positive acceleration is generally talking about when velocity increases. Excellent. All right, let's go ahead and talk a little bit about negative acceleration.
Actually the same thing as positive acceleration, except it's actually in the opposite direction. So acceleration, it's always going to be a change in velocity. Negative acceleration just means that you are decreasing your velocity, right? So either, remember, velocity means speed or direction. So you could be stopping your motion, going slower, but it also could mean, as we might explain later, that you might just be reversing your velocity in the opposite direction, meaning you're having a negative acceleration. But usually what we're talking about with negative acceleration is that you are slowing down or coming to a stop, as we can see with our car being an initial velocity of 6 going down to 3, and then from 2 to 0. All right, let's get smiley faces in the chat, or I'll pull up this little poll right here. Let's have some smiley faces to indicate that we understand this. All right, hopefully we're all smiley faces. If you don't understand it, do a neutral or a sad face. But I think this is pretty much solid. All right, awesome. All right, so let's move on to zero acceleration.
All right, so zero acceleration can be a little bit hard for us to wrap our brains around. Again, remember, acceleration means any change in velocity. So zero acceleration does not mean necessarily that you are not moving. It just means that your velocity is not changing. So yes, this could mean that you're not moving, that you're at rest, and you're staying at rest, right? You're going from 0 meters per second to 0 meters per second. That's pretty obvious that that's zero acceleration. But what's also acceleration is if you just maintain the same exact motion. So take a look down here. Imagine this car is moving at 10 meters per second and stays at 10 meters per second. This would actually also be no or zero acceleration because your speed and your direction is staying the same. Again, it's only if there's a change, and this right here is not a change, so there's zero acceleration.
Learn about acceleration. So doing some more matching again, please open up your whiteboard tools, get out those thin lines, and we're going to match up the type of motion with the type of acceleration. So we have our first one, which is stopping motion or getting slower, starting motion or getting faster, or maintaining motion or staying at rest. So just to confirm what I think we already understand is that yes, stopping motion or getting slower is negative acceleration. So imagine if your car and you're slowing down or you're about to come to a stop, that is negative acceleration. Starting motion or getting faster, so starting to speed up in a car or increasing your speed in a car, that is positive acceleration. Or if you're moving at a constant speed on a highway, or you're just sitting still, that is zero acceleration. All right. Please raise your hands for number 3 when you to indicate that you are done and ready to move on. So if anyone wants kind of a really helpful way to remember this, just think of acceleration as our brainstorm at the beginning of what you would feel in a car for that type of acceleration, right? So if you're moving faster, you're being pushed back. If you're experiencing that negative acceleration, you're being thrown forward. Zero acceleration, you're not feeling anything, right? Just like when you're traveling at constant speed, like on a bike or something, doesn't have to be in a car.
All right, let's go ahead and take a look at this one right here. This one is a complete on your own. So the Hogwarts Express is moving at 3.4 meters per second and continues at 3.4 meters per second. For several hours, what type of acceleration is this and why? Do not put answers in the main chat. If you need help, we're in the Q&A chat. But we can go ahead and actually answer the green part together. If it's at 3.4 meters per second and continues at 3.4 meters per second, tell me in the chat, is it maintaining the same motion, slowing down, or speeding up? We can actually answer this part together, and then the rest of it you will need to do on your own. So tell me in the main chat, is it maintaining the same motion, slowing down, or speeding up? If it's moving at 3.4 and continues at 3.4. Excellent, Lexi. Excellent, Jared. Excellent, Joseph. Exactly. So I'll go ahead and I'll broadcast this in your notes for question number 4. Again, we can see that for the green part, what it's doing. Awesome. All right, so that just means that you need to go ahead and figure out the pink part, all right, if that's negative, positive, or zero acceleration, if it is doing that. All right, so go ahead and, again, we've talked about those definitions. We just saw those in question number 3. Refer back to question number 3 if you need help figuring out what that type of motion means for acceleration. Raise your hands when you are good on number 4. Again, just do your best. You'll get partial credit if you get at least one of them right. So go ahead and raise your hands. You have 20 more seconds to raise your hands. All right, so let's go ahead and talk about how we actually calculate acceleration. So for acceleration, we need to know how is velocity changing over time. So that means we need to know the initial or starting velocity, which we measure in meters per second. We also need to know the final or ending velocity, which we also measure in meters per second because velocities are always measured in meters per second. And we need to know the time. Time is measured in seconds. So you can see here acceleration is the change in velocity, final velocity minus the initial velocity, all divided by time. The units for acceleration right here are going to be meters per second squared. All right, the way that you're going to end up writing this today, just so you know, is meters/seconds with a little caret and the number 2. That's how you need to write it in your unit box of all of your answers. Otherwise, the computer will mark your units as wrong. Smiley faces, emojis in the chat box if that makes sense. This is how you are going to write it in your units box for your answer. Okay, meters/seconds with a little caret and the number 2. Okay, excellent. Let's go ahead and actually try an example out. So we have a car moving at 6 meters per second, and it steps on the gas for 2.1 seconds until it's moving at 9 meters per second. Let's go ahead and annotate together. So 6 meters per second, what is that? Take a look over here. We said meters per second is a what? A velocity, a time, or an acceleration. Meters per second, no number 2. So take a look here. Is that a velocity, a time, or an acceleration? Thank you. I see Lexi in the chat. Let's get some more answers. Meters per second, is that a velocity, a time, or an acceleration? Excellent. I see Amari working in the chat. Thank you, Itati. Thank you, Lena. Yeah, it's a velocity. We said both of these velocities, initial and final, are measured in meters per second. Now, which one is it? Is it our initial starting velocity or our ending final velocity? So car's moving at 6 meters per second, steps on the gas until it's moving at 9 meters per second. So 6 meters per second, is that the starting? Yeah, awesome. This is going to be our initial. All right, Jonathan, you still need to stay here because, again, we still do make sure that you are in class the entire time. All right, so this one is going to be our VI, our initial, okay? Now, 2.1 seconds. Seconds is what? Tell me in the chat box. Seconds is our unit for what? Again, is that a velocity, a time, or an acceleration? Yes, we should know this. This is definitely going to be our time. Nothing special about that. And meters per second, again, this one is still a velocity, but this time, what type of velocity is it? Initial or final? Initial or final? Awesome, Jonathan. You are ahead of the game then. Yeah, it's what we're ending at. So this is going to be our V final. Perfect. Let's go ahead and start plugging these things. So based on what we annotated, what do I plug in for my final velocity here? Take a look at what we just annotated. That's why we annotate, to make our lives easier. In the chat, work quickly. We have to get through a couple of these, so work fast. Nope. Final. VF. What did we annotate for VF? VF, F. Final. We start with the final velocity. There we go. I see those corrections in the chat. Perfect. Yeah, our final velocity was actually 9. Now we plug in our initial, our starting. So take a look back up here. What was our initial or starting? What was our initial or starting velocity? Thank you, Lexi. Thank you, Jared. Get some more answers. This time we're looking at our initial. Initial was what? Yeah, exactly. This one was our initial, our starting, which was 6. And our time, what number do I plug in for time? We'll need a calculator, so great. Yeah, 2.1. Awesome. So now, don't forget that based on our order of operations, PEMDAS, we always need to do parentheses first. All right, so take a look at what's in our parentheses. 9 minus 6 equals what? 9 minus 6 in the chat. 9 minus 6 equals what? Work quickly in the chat. Thank you, Mari. Thank you, Lexi. Jared, yeah, this equals 3. And again, we still just pull this down, so we still need to divide by 2.1. Grab your calculators and tell me, what are you getting? I only need one decimal place. What is 3 divided by 2.1? Tell me in the chat. Start using those units. Meters/seconds, caret 2. Meters per second with a little 2. Go ahead and tell me in the chat. Use your units because, again, you will be expected to use your units in your notes. Awesome. I see an answer from Jared. Let's get some more people in the chat. Again, make sure you're actually using your calculator so that you know how to use your calculator, because the last question you have to do on your own. Thank you, Alex. I see you in the chat with those units. Lovely. Thank you, Cody, also coming in with those units. Thank you, Kalina. Yes, perfect. Get some more answers in there. Thank you, Lena. You should be getting 1.4 units, meters/seconds, with a caret and a number 2 to show you that it's being squared. Excellent job. This one is going to be our answer for number 5. Again, the number goes in the number box. The meters/seconds square with a little caret and a 2 goes in the unit box. This is number 5. Go ahead and raise your hand when you are good on number 5.
We have a car that is moving at 10 meters per second, right? So that's a velocity. And then it slows down to 2 meters per second. That's our other velocity. And then this all happens within 6.5 seconds. So with our 6.5 seconds, that's going to be what in the chat? What variable is our 6.5 seconds? Is it velocity or time? That is our time, yeah. So we can signify that with a T. And then our 10 meters per second, because it says that's happening first in the problem, is that our initial or final velocity? Initial, very good. So I'll put a little I next to that one. And then for our 2 meters per second, because it says it's slowing down to that speed, is our final or initial velocity? Or I guess just through process of elimination, right? That will be our final velocity. All right, so now we have to calculate what is our car's acceleration. All we have to do is plug these in, right? So what goes in this first blank right here, right? That would be our, let me change this to red. That would be our final velocity right here. And here would be our initial. All right, so let me type that in there. That's going to be 10. All right, and then our initial, or I'm sorry, I typed that wrong, but I'll switch it back. Thank you. Yeah, so our final is 2, our initial is 10, so make sure you get those in the correct order. So it's going to be 2 minus 10, and then divided by our time. So remember our time is 6.5. So I'm going to write 6 period 5. Dragging that over here. So make sure you have your calculators out, guys. Make sure you type it in the correct order in your calculator. So it's going to be 2 minus 10, which should give us a negative 8. And then we're going to divide that by 6.5. Remember, only one decimal place should be suitable. What are we getting in the chat? Caret 2. So let's write that in there. Yeah, so negative 1.2 S with a little caret that you can find up above your number 6 key on your keyboard, and then a 2. So that's what it should look like right there. All right, move that a little bit up. You guys 30 seconds to go ahead and raise your hand and tell me when you're done and ready to move on.
All right, so we're going to go ahead and annotate this one together because I know this is a new process, but then you do need to solve this one on your own. So again, you do need your calculators out. So that's why we were practicing. That's why I asked you to get your calculators out earlier. So an ice skater speeds up from 3 meters per second to 7 meters per second in 1.6 seconds. What is their acceleration? So in the chat box, meters per second, is that an acceleration, velocity, or time? In the chat box, is that an acceleration, velocity, or time? Meters per second, no little 2, no little 2. So what is this one? Excellent. I see Lexi in the chat. I see Jared in the chat. Yeah, it's our velocity. And specifically, is it our initial or our final? If we're starting at 3 meters per second, is that the initial or final? Thank you, Lexi. Thank you, Jared. More people in the chat. Initial or final? Work quickly. We're out of time. But we need to finish this question. So the faster we go, the faster we can dismiss you. Yes, Kalina. Yeah, this is going to be our initial. What about 7 meters per second? What is that variable? What we have left over is it could be acceleration, final velocity, or time. 7 meters per second must therefore be what? Our acceleration, final velocity, or time. Thank you, Jared. Thank you, Lexi, Kalina. No worries, Jonathan. I need more people in the chat responding. Alicia, Joseph, Carlos, Kamal, Callie, Shayna. 7 meters per second must be the what? 7 meters per second must be the what? We already have an initial velocity, so what is 7 meters per second? Thank you, Itati. Thank you, Kamal. Yeah, this is our final velocity. And then last but not least, 1.6 seconds is our what? 1.6 seconds is our what? Yeah, our time. So if I were to plug this in, I should have our final velocity, which is 7, minus our initial velocity, which is 3, and divided by our time, which is 1.6. Don't forget to solve what's in the parentheses first before putting that into your calculator. Here's a note here. We are speeding up, so if our speed is increasing, our change is increasing, then their acceleration should be what? Positive or negative? We talked about this earlier. Even without doing the math, our answer should be positive or negative because they're speeding up. Tell me in the chat. Should our answer be positive or negative? Thank you, Joseph. Thank you, Erica. Thank you. Or sorry, Kalina. Thank you, Jalen. Thank you, Lexi. Yes, so your answer should be positive. Okay, so keep that in mind. That eliminates 3 of those possible answers. Do the math. This is number 7. Raise your hands when you are done. You have 20 seconds if you need help. We're in the Q&A area as always. Don't put answers in the main chat though. Thank you. We talked about forces and acceleration. We talked about the different types of acceleration and also how to calculate it. I'm going to go ahead and skip this right here. Go ahead and submit it. Let us know how you